All right, so I've tried to draw a picture of what's going on here. We have Alex running, gets himself up to a speed of 8 meters per second when he grabs that rope, and he's going to swing hopefully across this pool of water below and safely onto the next platform. These hosts, they made it extra tough. They put this in a wind tunnel, so there's wind resisting him as well. The question is, what will Alex's speed be at the bottom of the swing? And the bottom of the swing is 5 meters lower than where you took off from. So I kind of try to draw that in yellow there. All right, this is going to be just a conservation of energy formula, not conservation of mechanical energy, just conservation of energy in general. And the general formula looks like this. This is one way to express it, the more compact way. So the change in Alex's mechanical energy will equal to the work done by the non-conservative forces, which in this case is just going to be the wind, which is negative 1,000 joules. That's what's going to go in that W and C variable. The only other forces acting on him would be gravity, which is a conservative force, and also tension. But tension does not count towards W and C because tension is actually always 90 degrees to Alex's motion. He's going to swing in a circular motion, and the tension is always going to be perpendicular to the way he's moving. So that 90-degree angle actually means that it will not do any work on Alex. Cosine of 90 is 0 degrees. Okay, the other way to express this formula is M1. This may be the easier way, actually. It starts out longer. Not M1, K1. It starts out longer, but if you started with the more compact version that I wrote above, you're going to end up having to do steps that will get to this anyway, or get to essentially this. So I just might as well start by writing out the long form of this formula. This is the conservation of energy formula when you've got non-conservative forces doing work on the object. Okay, for this, I'm going to see if I can cross any of these out. Is there anything that is 0 here that I can cross out? Well, one of the gravitational potential energies will be 0 if I choose a smart reference level. So I could choose where he took off from as a reference level. Maybe I'll choose the bottom of his swing. I'm drawing it in green here. I'll choose that elevation to be the reference level. That way I don't have to deal with any negative heights, because he never goes below that. So if I choose that to be my reference level, I would say that gravitational potential energy 2 would be 0. No gravitational potential energy at that point. I believe that will be all. He has kinetic energy at the start. Hopefully he still has kinetic energy when he's still swinging down at the bottom there. And he does have gravitational potential at the start. So none of those other ones are 0. So now what we normally do is, we can replace each of these with their formulas. I actually like to do one rearrangement first. Since we're solving for the speed at the bottom of the swing, I want to get this isolated for K2. K, because kinetic relates to speed, and 2, because that's moment 2. That's when he's at the bottom of the swing. Well, you know what? This is already isolated for K2, so I guess that works out. So I will replace them with their formulas. So kinetic energy is half mv squared. I'll be careful to write subscripts for before and after. U is mgh. W and C, I'm just going to leave it as that, even though I know it's negative 1,000. And then on the other side, half mv2 squared. So now this just comes down to rearranging it to isolate for v2. And it looks like I'll do that by multiplying everything by 2, dividing everything by m, and then square rooting the whole thing. Or dividing everything by half m and then square rooting the whole thing. Here, I'll do it in a couple of steps. I'll show a couple of extra steps. What happens if I multiply everything by 2? Well, then the half goes away. And then the middle term becomes 2mgh. And the work term becomes 2 times work. And I'm also dividing everything by m. What happens when I do that? Well, the m's from the first 2 terms cancel, but the m from the third term, there's no m to cancel on the third term. So it's gonna, that one still has to be over m. So when I write out my next line, I'll square root everything at the same time. I can have v1 squared, I can have 2gh, and I have to have 2w over m. Okay, so that's how I would isolate for v2. I can go ahead and plug the numbers in. I'm just going to use where I have some more space here. So the starting speed was 8.0. G, the starting height is 5.0. I'm going to say minus, well, no, I'll say plus 2 times negative 1,000 divided by the mass of 60. All right, so let's get all that in the calculator. Okay, so I'm getting 11 meters per second when I round to 2 sig figs. All right, so he does speed up, he does pick up speed. He started at 8, he ends up at 11. That would likely be a lot less speed than he normally would if there was not that wind resisting him. Because basically this term here would just be removed if there was no wind there. All right, so that's the answer to this.